Hey, good morning. Uh, we are going to start a new lesson, and this is your very first flipped classroom, which is pretty exciting. So, in this classroom, you're going to be getting the exact same lesson, but it'll be at your own pace. You can pause, you can fast forward, you can replay over and over and over again. So that's kind of the one of the many perks to a flipped classroom. You need to be following along in your math books. We're going to go through this whole thing right in front of you here. So we're going to start on 10.1. When I tell you to pause it, do what I tell you to do, then hit play when you're done, and we'll pick up right where we left off. And I think you're going to enjoy it. Classes in the past have. So today we're going to start on 10.1 modeling and writing expressions, kind of your first introduction to algebra, if you will. So writing an algebraic expression. I'm just going to read right off the top here, if you can see my screen. An algebraic expression is an expression that contains one or more variables and may also contain operation symbols such as addition or subtraction. We'll have multiplication and division later. So a variable is a letter or a symbol used to represent an unknown, and we've talked about that. A lot of times they'll use X or Y, but it could be any letter. A constant is a specific number whose value does not change. So an example here of an algebraic expression is you can have just X, you could have W plus N, both variables, but a constant would be like 150 plus a variable Y. Okay, so a constant never changes. Y is an unknown. That's also known as a variable. In an algebraic expression, multiplication and division are usually written without the symbols X and division. A lot of times the multiplication is a dot, or it can be parentheses we talked about. And then division is written as almost like a fraction. We know that a line and a fraction means divide, right? So 3 divided by n is 3 over n, like you see there. These are some great words to look for. I bookmarked this page. When you hear the words added to, plus, sum, or more than, you think addition. When you see the word subtraction, when you see subtracted from, minus, different, less than, you're thinking subtraction. Times, multiplied by, product, groups of, multiplication, and division is divided by, divided into, or quotient. Okay. So we're going to practice here. So first example says, write each phrase as an algebraic expression. So they're going to give it to you in words. I want you to write it as an algebraic expression. So it says the sum of 7 and x. So this is why you want this. Okay, so you want to be able to see what some of these words are and what they mean. So sum is right there. So sum tells us we're adding. So we're going to, the sum of 7 and x. We're not solving. We're just writing equations. So that's it. Boom, done. The algebraic expression of 7 plus x. Boom. Okay, so that matches what they said. The quotient, when you see the word quotient, we already know this one. It means divide. And z and 3. So z is being divided by 3. And that matches what they're doing here. Okay. So again, we're not solving. We're just writing algebraic expressions. They're going to give it to you in words. We got to put it into an algebraic expression. They'll also give you the expression. You're going to have to put it into words. So that's why this page is so important that you have this bookmarked, because you can use these types of words when writing these equations. Okay. All right, next page. Let's do your turn. So this is how your turn works. You're going to pause it. When I say go, you're going to pause it, and you're going to solve 1, 2, 3, 4, 5, and 6. Follow the directions. Then when you hit play, we'll go over it and see if our answers match. Okay? So hit pause now and solve 1, 2, 3, 4, 5, and 6. Go. Okay, welcome back. Let's see if you get this right. It says write each phrase as an algebraic expression. N times 7. So you should have n times 7. Remember, we're getting away from the x. 4 minus y. 4 minus y. 13 added to x. Okay? And it says write a phrase for each expression. So I'm just going to tell you what I would write. I'd say the quotient of x and 12, because that's a division problem. You could say 10 times y, and the sum of c plus 3. You don't have to use those words. You could use any of these words found over here. Okay? But those are the ones I would use. Okay? Now we're moving on to modeling expressions. Modeling expressions is just a tool. So if it's one of those things you don't really quite understand, that's okay. It's just another thing to help you. So if we use this bar model to represent the following expression, 7 plus x, we have 1, 2, 3, 4, 5, 6, 7 boxes to represent our constant, 7, and then one big box to represent our variable, x. Okay? Then we have divided z into 3 equal parts. So if we had z divided by 3, this whole thing would be z, and then we're cutting it into 3 boxes. Okay? Just another way to kind of help you visualize what's happening here. So let's try your turn. We'll do 7 together, and then I'll have you do 8 on your own. Okay? So let's do t minus 2. So t could be this whole thing. And then we could color in, sorry, this isn't great, but we could color in these 2 pieces. That's why I have t minus 2 of them. Okay? So we could also do 8 for 4 times y. So I'm going to have you pause me now and try to come up with a way that you could represent this box to represent 4 groups of y, or 4 times y. Go. All right, welcome back. So if you were like me, you'd cut this puppy into 4 groups, and then each of these would represent a y. So you'd get 4 times 4 groups of y. Okay? All right, so we're going to kind of move on. We're going to model some real-world situations. Okay? So here's how it works. I'll give you the example, and then you guys are going to come down here and do the guided practice on your own. All right? So let's work on this last piece, and then you're done with me. Tickets to the water park cost $53 per person.
Roman Duran, please go to Mr. Cano's room. Roman Duran to Mr. Cano's. Thanks.
We've got announcements after school. So it says, write an expression to show the total cost of tickets for a group of people. So tickets at the water park were $50 per person. Write an expression to show this. Okay, so a group is a clue to multiply. We got more than one person. You don't want to just sit there and add up multiple people. The faster way is to multiply. The ticket price is 53. That's our constant. It means that the charge isn't going to change. The number of people who needs is a variable, meaning they didn't tell us how many people are coming. The algebraic expression for the total cost is 53x. Or you could write it, if that bothers you, you could just write it as 53 dot x. 53 times x. Okay? So it says, there's our next one. If you want to read that, that's fine. I'm going to move into your turn. We're going to do this guy together. So it says, Helen divides up some money to give equally to her 4 nieces. Equally tells me something here. If D represents the total amount, write an expression to represent how much money each niece receives. All right, so breaking things up into equal groups. Man, that sounds like division to me. Okay, so what's being cut up here? Do we know how much is being cut up? We don't. It says D represents the total amount. So D is going to represent what's being cut up. Okay, do we know how many people she's cutting it up between? We sure do. Her 4 nieces. So this would be D divided by 4, or D over 4. Okay. Boom. Real world problem. We wrote an expression. This is like what you would do to solve this, or maybe if you were running the park that has the tickets, this would be your equation. Then all you would have to do is you would have it all set up. You'd have 53x, and then all you'd have to decide is, okay, how many people you got? 53 times, okay. Then you can figure it out. Same thing here. Once Helen figures out how much money she's got, she knows she's got to divide it by 4. Boom, real world problems. Okay, so here you go. I'm done teaching. Now you're going to be on your own. If you need to watch that again, or if you have questions, just raise your hand. If you need to watch that 1,000 times, watch it 1,000 times. But this is your practice today. This is how you're going to get better. So today you're going to learn how to write algebraic expressions and model them. You are in charge of this guided practice page, okay? That is going to be the next page on 265. Once you complete 265, please raise your hand. We'll come and check your work, see what you got going on, give you any suggestions we think. If you get 100% accuracy on this, then you will move on to the independent practice. Okay, on the left-hand side, we've got some basic drill and kill. On the right-hand side, we've got some deeper level questions. That's where we really want to hit it home. Okay, so I hope you enjoyed your first flipped classroom. If there's any questions you have, again, you can either watch the video again or you can ask me personally. Raise your hand. If you want to take notes in your notebook, you can do that. Watch it again. Take notes if you need to. If not, it's all found here in 10.1. All right. Good luck on the guided practice. Remember, raise your hand when you're done, and I'll come to you. Hopefully, you get 100% accuracy, and you're on to 10.1 independent practice. All right. Hope you enjoyed your first flipped classroom.